But when you're working with certain problems, like if I ask you to solve x squared equals 16, there are two solutions to this. Okay, if you take a square root of both sides, I put the plus or minus in front because there are two solutions. It's plus or minus 4.
Oh, okay.
Right?
Yeah.
Now, it could also be, let's say it's x squared equals 7. The process is exactly the same. You're going to take the square root of both sides, and it's plus or minus the square root of 7.
Right.
So x equals plus or minus the square root of 7. And if I said, hey, Emma, what are the two solutions? You're supposed to say square root of 7 and minus square root of 7.
Okay.
So these always come in pairs. And they're, I mean, maybe that's not the right wording. You could think of twins, but we sometimes refer to twins, biological twins. You could have a male and a female. You could have two. I mean, you could have a lot of variation on that. In math, when we refer to this, we're saying they're the same except for the sign. Okay. So if I tell you, and specifically we're talking about roots right now. If I tell you that the square root of 11 is a solution, what also must be a solution?
Negative 11.
Right, square root of 11. And if I tell you that negative square root of 43 is a solution, what must also be a solution?
Positive square root of 43.
Exactly. So it works similarly with complex solutions. Okay, and that's the I business you were starting to see. So for example, let's say that 4i is a solution. Well, so is minus 4i.
Okay.
Let's say negative 5i is a solution. Well, so is 5i.
Right.
Okay, and it continues. Like, let's say it's the I times the square root of 3. It is also minus I square root of 3. It's exactly the same except for the plus or minus. Do you see that?
Yes, I do.
Okay, now it gets slightly more complicated. We'll deal with that if it comes up, but that's kind of the lead in to this type of problem here that we'll maybe first start with. But actually, we don't actually have to quite get to that. Let me snip in question 1. And I really hope you were seeing my screen the whole time.
Yes.
I have bumbled that. I have bumbled that a few times, and I apologize.
It's
again.
totally fine. I would do the same if I was in your position.
Yeah. Okay, so this problem is kind of unrelated to everything we just did. I probably jumped into that a little too soon, but the when you write a polynomial function f of x, there's always this thing a out in front. A is the leading coefficient. Okay. And then what you do next is you write x minus the root, whatever it is, x minus the root, whatever it is, and you repeat. You just do this over and over again. Okay.
Yeah.
Until you're done for however many roots there are. So this one has 1, 2, 3 roots. Okay, it says the leading coefficient is 1, so it says a is 1. There's a. X minus a minus 4. X minus 2. X minus 9. And then there's one more root, x minus a minus 5.
Yeah.
Okay. Now we have to deal with this multiplicity business. So the multiplicity is the exponent. Okay. So I can't really fit it in here, but the multiplicity goes there. So when multiplicity is 1 means it has an exponent of 1, 1, and 1, but the last one has a multiplicity of 3. So when you simplify this, and I don't mean multiply, I just mean kind of write it a little bit better without all the operators. Right. It would be x plus 4, and you don't write to the power of 1. You could. I don't think the solution does that. X minus 9, but then it becomes x plus 5 to the power of 3. This is considered in factored form. There are problems where you have to multiply all of these together. I'm not seeing any here, but that is the case. So the multiplicity is the exponent. The root is, it's always x minus the root, x minus the root, x minus the root. Is that okay?
Yeah, that's okay.
All right.
I've actually seen problems where we actually had to factor it out. Sorry.
So expand it and
it.
Yes.
It's really hard. And well, like not like super hard. It's just so much work.
It's a lot of steps. Yeah. All right. So this is related. Now we're skipping to 4. We're going to go back and do 2, but we're skipping ahead to 4. This is related to our discussion from earlier. When the instructor says which polynomial function has leading coefficient of 1 and roots, you know that it's kind of like the last one. But the first root here, I'm gonna do it differently this time. The first root is 2i, and I mentioned that it means that they come in pairs.
Right. So we have negative 2i also.
Yes.
But why is it sometimes we have pairs and sometimes we don't? Like
so they don't apply to whole numbers.
Okay.
But they apply to and the reason reason that matters here is because this other root 3i means it also comes with its pair minus 3i. Okay, so now again, the way you write this is you have your a, and then it's x minus the root, x minus the root, and so on. Okay, right. And these are all roots. So it said a is 1, so you write it this way: x minus 2i, x minus minus 2i, x minus 3i, x minus minus 3i.
And then we have to like simplify it, right?
Yeah, and in this case, all that means is you're gonna deal with the negatives. So it becomes x plus 2i, x minus 3i, x plus 3i. The order does not matter because you're multiplying. So if they're scrambled, meaning like x plus 2i comes first, that's okay.
Right. That makes sense.
Is that okay?
Yeah, no, that makes sense.
All right, let's look at number 5 now. 5 is kind of that question you were just asking. It's like, well, when do you find its pair and when don't you? And it only applies to roots and complex numbers. Okay, so this one has roots minus 4, I, and then 2. Okay, and what's like encoded in this is that you're supposed to also know that that includes minus I.
Right, because it's not a whole number.
Right, but for these other ones, it's just minus 4 and 2. Okay. It actually has a really interesting question because it isn't structured well, like why this is the case in terms of like the way it's presented to you. Because a really reasonable question. Well, hey Matthew, why isn't it 4 minus 4 and 4, 2 and minus? It's totally reasonable. Like now that we're talking about this, to think that I actually don't have a good answer for why it is. It's just the way it is. But this time
you're curious because I was kind of like, wait a minute, we didn't do that before. That makes it feels like you should.
Right. It feels like it feels like it's it feels like it's misleading, but
that's okay. I mean, whole numbers, that's a pretty good explanation. I mean, I think I'm
Yeah.
on board with them, so.
Yeah. Well, I think as a student, you sometimes know when instructors or people are helping you aren't really giving you the full, and pieces of information. And I truly don't have a good explanation for this at the moment. The leading coefficient though is 3.
Mhm. That goes out.
Okay, so then it's x minus a minus 4, x minus I, x minus a minus I, x minus 2. And you're welcome to, like, you don't have to write it out like this. You can easily combine the negatives if you want. Just whatever you're comfortable with, if your exam is matching.
Right. And we leave the, like, I guess in this we leave the 3 alone, but usually we would factor the 3 in, right?
So the right wording is you would distribute or multiply, but in this case, you don't need to, because it's left in this factored form.
This is, I want to say factored, but obviously this is its factored form.
Yeah. It's kind of like the 2 words solve and simplify. We can kind of use them interchangeably, but they're actually very opposite with one another. Another one that you see used is accuracy and precision, although it's a slightly different context. You know this because you're really good reader. I mean, words have to be used correctly to give the right meaning.
Yeah.
But sometimes in spoken language, we get away with misusing our language.
No, we in chemistry went over accuracy and precision. It was just super funny. They had like a target and accuracy, like all the arrows were in the middle. Precision, yes. They were on the side, but they were all in the same spot.
Yep.
So,
yep.
Like they were technically precise in where they landed.
Right.
And then the other one's not accuracy and not precision at all, and they're just all over the place.
Yeah. So when you're flying or when you're doing stuff related to that, have you heard these words used in that context?
Yeah, I have.
I mean, if you miss your landing, but you're really precise, I don't know if that's good or not, but I would assume accuracy is the key one.
Yeah,
there.
It's more like the accuracy, landing and stuff. But even with cars, the accuracy of how much gas you have to put like on your pedal to like how fast you're supposed to go on the speed limit and everything. That's
yes.
That's crazy hard. I have a hard time with that.
It's understandable. Yeah, driving is it's fun, but it's got its challenges. So, all right, let's look at 6, and I kind of already answered this question from earlier, but you're looking at 3, and like basically 3 doesn't pair up with anything.
Right.
But what about square root of 7?
Square root of 7 goes, you have to have the negative of it because it's not a whole number.
Yeah, but the square root of 7 comes with a pair minus square root of 7.
Mm-hmm. That was a pretty easy one, I guess, once you figure it out.
Yes. Okay, so now we're going to go back to 2, and I've got to give you more information to do 2. So before I do 2, I again, like, this is kind of a full disclosure here. I mean, so roots can also be presented this way. It can be like 2 plus the square root of 3, and it's paired with 2 minus the square root of 3. So notice the only thing that changes is this right here.
Right.
Okay. Now I could give you something like this: minus 4 minus the square root of 5, and it's paired with minus 4 plus the square root of 5. So again, the only thing that changes is what's in front of the root. The number in front you don't manipulate.
Mm-hmm.
Similarly, or analogous to, and I probably just misused that, the language now that we start thinking about it, complex numbers. So like if I tell you it's 4 plus 3i, that is also paired with 4 minus 3i. And again, all you're doing is switching this right here.
Switching the sign in front of the not whole number, the root.
All right. The next thing here is like, what if I say minus 3 plus square root of 5i, which could happen. It pairs with minus 3 minus square root of 5i.
I don't know why they make it so complicated. But I and a square root.
Yeah, there could be a lot going on. So now we can actually answer question 2. All right. So which polynomial function has a leading coefficient of 1? That's good. And roots 7 plus I. So that means that there's also root 7 minus I. And then there's a 5 minus I. That means there's a 5 plus I. Okay, so your function is a, which is 1 times, and this is where you gotta be really good with your parentheses, minus 7 plus I. So I'm taking this whole thing and I'm putting in parentheses, like I'm not trying to distribute. And you do the same thing for the other one here. Okay, we will distribute the negative, but not yet. Well, actually your answers are written. Well, yeah, your answers actually are written this way. So x minus parentheses 5 minus I, x minus 5 plus I.
Okay, it's a lot of parentheses.
Yes.
You do that with like all the examples you gave above, like with the minus, like if they're more than just one number, you put them in parentheses. They're like equation, I guess, or complex number systems.
Yeah.
Parentheses in a different way.
Do you feel like you understand? Do you feel like you understand that? Do you feel like you could reproduce that?
Yeah, I feel like I can.
Okay. So why don't you look at number 3 on your own here? I need to just mute myself for 30 seconds. Why don't you take a look at number 3 and see if you can answer that on your own?
Okay.
All right. How is that going? Is it clear?
That was a lot more easy. That was a lot easier than the first time I looked at my homework.
Which answer did you select? Or
I
can you
did
tell me?
3 minus the square root of 11.
Perfect. Okay, so I think we've done 1, 2, 3, 4, 5, 6. Is that true?
Yes.
All right. So the way to do, actually, there is an 8 and there is a 9. We'll do 9 next, and we'll go back to 7 and 8. So 9 is the one that no student wants, because you not only do you have to write it out in factored form, you then have to FOIL it, and meaning expand stuff, and it's just horrible. It's just messy.
Yep,
Again,
some of these in class and hated them.
Yeah.
I'm also not the greatest at them. That's why it's still in the homework.
Yeah, it's not great. What is the one that's paired up with I? What goes with I again?
Negative I.
Perfect. Okay. So you do the same thing. You write it out in factored form. That part is no different. 1 x minus I, x minus a minus I, x minus a minus 2, x minus 2. So I'm just gonna apply the signs here. Okay. All right. So it looks worse than it actually is. get over the mental hurdle of how difficult it is. You just say, okay, I got to tackle this piece by piece. We're actually work on this first one here. We're going to FOIL it. First, outer, inner, last. It looks like the following: x squared plus xi. The order doesn't matter. If you want to go ix or xi, it does not matter. Minus xi. You should keep the order though. Like if you go ix, then do the minus ix here. Minus I squared. Now here's the part that I guess maybe they don't imply, or they should imply, really emphasize is that when you FOIL these conjugate pairs, which is the correct wording here, the I goes away if you've done it correctly. And maybe you see that here. Maybe you say, okay, I see that, Matthew. I see those go away, but what about this on the right?
Yeah.
What is I squared?
I squared, isn't that like 1?
-1.
-1.
So this becomes x squared minus a minus 1, which becomes x squared plus 1. So this line right here becomes x squared plus 1.
Okay. Got it. Then we FOIL 2.
So now we need to FOIL the other one. Maybe you're already onto that task.
Yes.
And this is where, as a student, you feel really good, like, hey, I know how to do this part, but it's a synthesis problem. You have to keep going. You have to not only do the individual FOIL, you have to then do another one.
Yep. It never stops. Okay, so I do have a question. What
Yes.
I've seen on the screen. Don't we have to have like, we have an x4, so then I know like we don't automatically have one, but don't we have to have like an x to the 3rd power?
You would think that because you're probably seeing them in descending order. So the way you get an x cubed is one of these x squareds would have to go to just an x, but then you wouldn't get an x to the 4th. Basically, it's because these exponents match. That's why you're not getting that x cubed. You're also not getting to the power of x either, or x to the power of 1. So like maybe somehow you said, okay, well, there must always be like in descending order, a 4th power, 3rd power, 2nd power, first. It's not always the case.
Okay. There's just the last few like lessons we've been learning that I'm like, wait a minute, now we're like disobeying that rule.
Sure. Yeah, you gotta know, when to apply the rule in what situation. And yeah, I mean, it's a good question to ask. You want to always ask questions, always get the information you want to be able to answer it correctly.
Okay, so we don't take it any further from here, right?
This is done. This is
done. Yeah.
Yep.
Paper, I would have known that. Yeah. Okay.
All right, so we're gonna look at number 8, and there's a couple of, I'm sorry, number 7. There's a couple of ways to do number 7. The first way is to literally graph each of those and see which one is the same. Okay. But we can do slightly better than that. Okay. You probably have so do you see that these are all cubics?
Yeah.
So there's 2 types of cubics in terms of their shape. One starts low and ends high. Like you could imagine it goes up and then it comes down and it goes up like that.
Okay.
And this one has a leading coefficient a greater than 1, meaning it's positive. I'm sorry, greater than 0. meaning it's positive.
Mhm.
The other possibility is the cubic starts high and ends low. Okay, and this is an a less than 0 or negative. And this is referring, the a is referring to the leading coefficient. So is it an x cubed or is it a minus 2x cubed? Which, like, basically I'm asking, can we exclude a and b, or can we exclude c and d now that you know? Like, which one does it look like? And I'm not trying to trick you. Like, I'm
I know
literally,
you're
yeah.
not. I'm just trying to figure. You leave the two.
So these are the two possibilities down here because they have negative leading coefficients. Do you see the negative in front?
Yes.
And this one starts high and ends low.
Yes.
Okay. So from here, not really a lot of good options. Again, like if you just graph it, you'll get the right answer. But let's do this. Let's factor out the GCF from the first one. I think we were doing that the other day. And in this case, it's a -2. So you're going to divide each, I'm sorry, -2x. You're going to divide each of these by -2x.
Right. Okay.
So let me know what goes in each of these positions, please.
So that's x to the third.
There's a 1 here, 3 minus 1.
That's 2.
2.
It's square power. X.
Okay. Minus.
Minus that's 12. I mean, sorry, 6 is what I said in my brain.
Yes. Yes. Okay.
Okay.
Now this one does factor nicely. You need two numbers that multiply to -6, but add up to +1. Do any of these combinations work? These all multiply to -6, but do any of them add up to -1?
Yeah, the last one.
The
2
last
minus
one.
3.
Yes, so x plus 2, x minus 3. Perfect. Okay, now if we were to set this equal to 0, I know there's a lot here. We got to, I mean, this is, again, the easy way is to literally just graph it, but there's no learning in that. So -2x equals 0, x plus 2 equals 0, and x minus 3 equals 0. All I'm doing is setting each factor equal to 0.
Right.
Okay, and then you solve each factor. So the first one you divide by -2. So you get x equals 0. Second one you subtract 2, x equals -2. Third one you add 3, x equals 3. Okay, and I didn't tell you why we were doing all this, but now I will tell you why we were doing all this.
You weren't just making me do a bunch of problems.
Yeah, we're gonna be smart about it. So what we're doing here is we're first saying, okay, we think it's answer C, because if it is answer C, then we've got it. But if it's not answer C, then we know it's D.
Yeah.
Answer C has 3 places where it crosses the x-axis: 0, -2, and 3.
Right.
So let's go back and look. Is that true here? Does this one cross at 0, -2, and 3? The answer is no.
No.
So therefore it must be letter D. And I didn't know. I was truly just guessing, but because you would, I don't have a good way to factor trinomials on my own.
Doesn't make sense. So luckily with these, they made it obvious there was only 2 answers. Well,
Yes, that's the first part. So the next one we can do very similarly. No. 8 is actually much easier. I guess I didn't look that much ahead. So okay, so to determine the factors, you first need the zeros. Okay. The zeros are at -6, comma, -3, comma, 0.
Yeah. Why do we call them zeros?
They're cropped. Well, there's actually several names from they're x-intercepts, so maybe that's more descriptive. They are solutions.
Okay.
Sometimes they're called crossings, but these are it. So the way let me scroll up here just a little bit. We're going to come back to this.
Yeah.
I wrote somewhere. I wrote x minus root.
Yeah.
Minus root. Okay, and that's another word for these two, by the way, is a root.
Okay.
Okay, so you can go x minus your root here.
Okay.
So be like x minus -6, x minus -3, x minus 0. So this becomes x plus 6, x plus 3, and then just x. And the question is asking you which of those 4 do you see here?
X plus 6.
Yes. And I'm sorry, if you ever need me to clarify which one to choose, please do that. I've lately, I feel like I've just been leaving it up to you to decide, but
it's okay.
I'm always
this
here
one was pretty obvious
to confirm. Trust but verify. If you, yeah.
There are a few times where I'm like, wait a minute, what? Okay, I should probably ask.
Okay, so we've got some time here. Is there another assignment you want us to start on? Test prep.
I mean, if we want to do like state testing prep questions, that would be good. I don't really have any other like homework that I have available to like do like right now. So
okay,
if we can do like something like that, I guess that would be pretty helpful.
Yes. All right. Let me start with the question of the week that I put up. I'll see if it's a good one or not. I don't actually, it's on an auto rotation, so sometimes I don't actually know what it is. So we'll see. Hopefully it's a good one. Yes, this is a good one. Okay. Okay, here is the question. We'll read it together. If f of x equals zx plus t over negative x minus 3, what is the value of z if f inverse, that means inverse there, is undefined at x equals -4?
Okay.
So there's actually kind of 3 things here. The first is like, can you find the inverse?
The inverse is the opposite, pretty much, right, of what's there.
It has. I mean, that that I don't want to be too harsh on your language. Like, it could be considered the opposite. The inverse means that you switch x and y. Do you remember that?
Yes, I do.
Okay. So, and then you solve for y. Now, sometimes they are truly opposites or flips, but this is truly referring to the math inverse, which is the recipes, switch x and y.
Okay.
So wherever you see an x, you put a y, and wherever you see a y, you put an x. Okay. All right, so now the goal here is to solve for y. Any idea how to proceed from this step here?
You want to get y out of the fraction.
Well, we definitely need to get it out of the bottom here. So what you can cross multiply here, or you can, it's the same thing. You can multiply both sides by minus y minus 3, like this. And you see that they cancel. So this becomes minus y minus 3 times x equals zy plus big T.
Yeah.
Okay.
And then you minus t, right?
Well, we got a y on both sides though. So you actually need to distribute this 3 first, or I'm sorry, this x first. So you get minus xy minus 3x equals zy plus t.
Right.
And so now we want to get these on the same side. Okay. And it doesn't really matter which way you go, but the preference is generally to like, well, there's kind of like always move left, and that does work. Always move, but like this time I'm actually going to add xy to both sides because
you don't want the minus sign.
Yeah, and that's just my preference. That there's not a wrong here. You also can subtract t from both sides. So it becomes minus 3x minus t equals zy plus xy. On the right here, you're going to factor out a y. And we'll go z plus x minus 3x minus t. Okay.
Yeah.
And then you divide both sides by z plus x. Okay, so the final here is minus 3x minus big T, and then it's big Z plus x. That is your inverse. So on a scale of 1 to 10, where 10 means you understood this perfectly and 1 means you didn't understand any of it, how would you rate your ability to do what I just did?
I would say 7.
Okay, excellent.
I understand what you did, and I've done it before, but every time I hear like inverse or whatever, like everything completely goes out of my brain and it just goes fear. What is that again?
Yeah.
Like what?
Okay.
What's the formula?
So we're gonna come back to this, but let's do another problem like this where I actually have you find the inverse of something very similar, but this time I'm gonna put numbers in it. Okay, so 2x minus 3, and I'll go let's go minus 4x plus 1. Okay. Right, and I want you to determine, the question is, what is f inverse of x? Okay, so take 2 minutes here. I'm going to mute myself. Take 2 minutes and just, again, it's the same problem. It's the same thing we just did, except there's no letters. It's just x and y's. Don't forget to switch y and x, but I want you to come up with the inverse here. I'll give you another minute here because I just talked. So go ahead and get started on that, please. I'm going to start working this out, but you can look at the screen if you would like, or choose to wait until the end. This is the step where there is a choice to be made. I'm going to choose to move it, the y term to the right and this other number left to make things nice. So if you didn't do that, your answer might appear slightly different.
No, that's exactly what I did.
Perfect, because it's one of the challenges with this question is that there's a few different ways to present the answer, and students sometimes like, well, which is the right way? I'm like, well, it depends. So not that easy to grade in some ways. All right, did you get this? Did you get y?
The step right before it.
Okay.
Yeah. Do you know how you got what you got? So then we divide it by 4. Y equals 3 plus 1x over 4x plus 2.
All right, so I'm gonna add another one in here just in case you want to try something later. You know, you're welcome to try this on your own later, but let's get back to the problem at hand. So the second part of the question, it talk about something being undefined. Now, when you have division in a function, do you recall what could be undefined? What, you know, in math, I joke there's like 10 commandments in math. It's actually only 2 for the moment. Well, the first commandment is division by 0. Like, thou shalt not divide by 0.
Right.
You cannot divide by 0. Like, that's totally not allowed. So a function is undefined when the bottom equals 0.
Oh, okay.
Okay, so let's say I tell you f of x equals 5x squared minus 3x plus 7 over x minus 4. And I say, where is the function undefined? You would set the bottom equal to 0.
Okay.
And you would say that x cannot, well, actually it's a cannot be 4.
Right.
X cannot be 4. Now, kind of in the spirit of some other problems we're doing, let's say it was 1 over x squared minus 9. And I ask you, where is this undefined? What would you tell me?
I would say it can't equal 3.
Is that the only solution, only number that it cannot be?
It can't be -3.
Or -3. Very good. Okay. So now let's go back to your problem. So your problem, which way up here, right? So this is where we got to. Do you agree with that?
Yes, I agree.
So the bottom cannot be 0. And this is weird because it's a letter. Z plus x cannot be 0, but that means x cannot be z.
Oh, right, because it can't be. Wait, what? Sorry.
Well, the point is that like z is a number.
Right.
Okay. So it turns out in this problem that it actually is, it ends up being just c because of that. So it ends up being that x is really -4. Sorry, I scrolled way by this. Right here, it ends up being that -4 cannot equal z. So you divide, you end up moving this negative over for that. I must have missed a sign somewhere. Anyway, so this is the kind of standardized question that you might see. What did you find easy about it? What did you find hard about it?
I guess I found it easy knowing the steps, like as you're walking me through the steps, like again, as like almost a reminder. Because I did know the steps. Just once you told me what the steps were, it was like a reminder of what the recipe was, and I was able to do it. And undefined was a little bit hard because I'd never really heard that term before.
Mhm.
So that was probably the hardest part. I'm like, wait a minute, what are you saying?
So you mentioned a couple of things there, right? Like there's at least 2 steps here to be able to do this, and they're very separate. Like I can give you a problem where you find an inverse. I can give you a problem where you figure out where it's undefined. This problem meshes the 2 together. So on, yeah, and that's what you expect to see. Another thing you mentioned is the language, undefined. Okay, you're going to see language that maybe you're not used to seeing because your instructor at your school chooses to use certain words. Matthew uses certain words. You have to be able to use your skills to be able to say, hey, you know what, I think I know what that means, to be able to answer the question.
Right. Yeah, that's the hard part with math. Math always has one correct answer, but so many different people have so many different ways to get to that correct answer.
Yeah. Yep. We got to get you going down the road of whatever you think is easiest. So, so just to summarize, or a little bit of review here in our last moments. If you have a solution like the square root of a number, it is paired with the square root of that same number. Okay, so if it's the square root of 5, it's minus the square root of 5.
Right.
If you get like 3 plus the square root of 7, you also pair it with 3 minus the square root of 7.
Right.
Similarly with i's. So if it's I don't know, 12i, that means it's also minus 12i. And if it's 1 plus 6i, that means it's also 1 minus 6i.
Right.
Okay, and that's the key here to take away from all this. All right, well done. I hope you get some time with your family this weekend if you're celebrating. If you're not, hope you enjoy the weekend otherwise. And
yeah,
thanks again.
We can go visit my cousins. Hopefully, we do Easter, so it's a lot of fun.
Great. I hope you have a great time, and I'll send you notes here shortly, and I'll see you next time.
Thank you.
Have a great night. Bye now.
Thank you.